Hello everybody and welcome back to Microchip's Design Week 2021. I'll be your host today, Clifford Swartz, and today is day 6, the final day of Design Week. For those of you that may not know, Design Week is a 6-day virtual event where you get the opportunity to watch live demos, speak to real-life Microchip experts, and furthermore actually attend classes that those experts designed specifically for you. Today's topic, the final topic for Design Week, is ease of use. And before we dive into that, I'm going to throw it over to Wayne Freeman in the booth, and he's going to tell you a little bit about the event and how to participate. Hello, my boss.
Hey, Clifford, how's it going?
I am very excited. How about you?
I am super excited as well, primarily because this is day 6. All of us have been in the studio for 2 weeks, and now it's time to wrap it up and culminate in an awesome discussion with panelists on how to get started with like the most amazing tech on the planet. So
Absolutely.
It's very cool. So just to do a little housekeeping before we get started, we are broadcasting on YouTube, LinkedIn, and Facebook. So please take a minute, like the video, hit that like button. Don't hit it twice, just one time. And make sure you subscribe to the channels, especially on YouTube. Give us a follow on Facebook, yada, yada, yada. And also, please share this content with people who you think may benefit from it. The other thing is, I'm going to be in the chat. Please join me in the chat. Ask any question that you'd like. I'll be selecting questions from the chat to ask of the panelists. If we don't happen to get to your question, we actually do have other Microchip employees in the chat who will be able to kind of help answer some slightly off-topic questions for you. But if we don't get to your question, you can email us at livestream@microchip.com, and I'm gonna front run Clifford. He's actually gonna be answering the questions personally.
Every day. That's my main job, is what I do.
Not every day. You've let me, Alita, and Claudia handle most of the business on the questions.
It all balances out.
I'm so disappointed.
I'm sorry.
So, just to recap as well, if you have not registered for Design Week, and this is your first day and you don't really know what it is, go to microchip.com/designweek, go to the portal, click enter or register. Hopefully you've registered. If you haven't, come on, it's day 6. Basically, the live streams are just the beginning of each Design Week day. After we get done here, you can actually go in and watch several different talk tracks that are going to be relevant to today's topic. So I'm not going to go into detail here, but the guys on the stage will actually provide you a little bit of guidance on on which ones are going to be the latest and greatest. You should watch all of them, by the way.
Absolutely.
The other thing that you can do in our handy dandy portal here is request a one-to-one meeting with experts. So Clifford's going through the screen here. Basically, if you go down to ease of use, you can essentially you can request a meeting with folks that are going to be experts on helping you get started. If you want to talk to someone about your next project with machine learning or your IoT, you can also do that there. So that's very cool. You can chat with all the attendees using the chat function. And last but not least, the trivia piece.
Yes.
Now, this is kind of where you can win stuff. So if you go answer some of the trivia questions, you get questions right, you'll have a chance to be selected to win either a development tool at 99.5% off, or cold hard Amazon cash. And
not bad.
If you're in the chat and you have gotten some Amazon cash overboard, please let us know. We'd be happy to see that. Now, I've spoken for way too long, and I know that the gentlemen on the stage with you are ready to get started. I'm excited for the discussion. So good luck, gentlemen. Let's go.
Let's take it home. Thank you very much, Wayne. So we have 3 guests with me. Firstly, to my left, we have my favorite Kiwi, who, if you've seen the first 2 days of Design Week, you might recognize him. He's escaped the smart home.
Yes,
Michael Pierce, how are you?
Good. They let me loose.
We did let you loose.
I tore up the golf course on my UTV, so they kicked me out. So,
it happens.
So I'm here now.
And so to Mike's left, we have Josh Lee. Josh and I were together on the holiday special episode of Coffee
Yes.
Break, so it's good to have you back.
Thank you for having me back.
Always.
It's good to be back.
And then making his live stream debut, we have Brian. How are you doing?
I'm doing well.
Good to have you here. So these three gentlemen are going to break down three different approaches to getting started with some of our tools. My first question is for Michael. Michael, if somebody was to want to get started with 8 or 16-bit microcontrollers, where would you recommend they get started?
Well, if they're getting started, they probably haven't downloaded our MPLab X or anything like that yet, so you can go and try it online.
Right.
So we have 3 tools online now. MPLab Discover, which is basically a whole bunch of demos that you can get started with. MPLab Express, and the built-in code configurator, which is online as well. So.
Nice. And so the first one is Discover. Do you mind taking us through a little bit of a deep dive for that?
Yep. So Discover, again, it's online. You go into Discover, you put in some search keywords or select different, specific topics on the left there, and it will give you a whole bunch of different examples that something might be close to what you're looking at doing.
Nice.
And from there you can go to the GitHub where it's stored, or for some of them you actually have the option to open in MPLab Express.
Nice, and so that sort of gives us a good segue into the next topic,
yes.
Express.
So MPLab Express, it's almost the same as our downloadable tool. It lets you basically write the code, compile the code. It uses our XCA compilers, and it looks and feels very similar. It doesn't have all the features, but it has everything you need, and maybe a little more. And it also links in nicely with our Microchip code configurator as well.
Absolutely. And so to break that down even further, our code configurator.
Yeah, so this is our code configurator. This one is a new version of our code configurator, so it's still very fresh, and it's being improved, every week at the moment.
Constantly.
And because it's different to what people have been used to, as you can see on the screen here, it has this middle section. The left side looks about the same, and the bottom looks about the same. The right is used to be in the middle there, but this middle section actually allows you to see the interconnects between the peripheral and microcontroller and other features, and that's very new. And yeah, it's a good starting point. And you can I've actually ran it on my cell phone the other day just to see if it would work, and I was sitting there in Express, and I can't type anything on it though. But
no, but still, it's kind of amazing.
So it's genuinely web-based. So.
Very cool. And so one of the things you showed for the Express IDE is that we can link it to a My Microchip account. Is that a free account that people can make?
Yep, so the My Microchip account is free, and you actually need to log in to be able to use Express and Code Configurator, because that allows you to save and load there, and it keeps it within your account, so not everyone else gets it. And you can actually set up, I believe, the GitHub link. So if you've got your own GitHub server, you can actually link it to that, so you've got your own storage there. So
nice. So we have an easy way to find examples. We have an easy way to actually change the code and program, and then furthermore, we have an easy way to have code generated for you. So
yes.
It's a nice whole system.
All three.
All three.
All on the web. Absolutely ideal for students and people that have not touched our products yet and don't want to download the very large MPLab Express. So.
Absolutely.
Sorry, MPLab.
It's all good. And so that was 8 and 16-bit in a general sense, but let's say one of our customers wanted to design something in an analog focused, as many of them do. Josh, do you mind telling them how they should get started?
Yeah, absolutely. On the analog side, we definitely want to start with MPLab Mindy Analog Simulator.
Gotcha.
So Mindy is our comprehensive analog circuit simulator. The end goal of this is basically to help the user minimize design risk and also the time that it takes to design as well too. I would say some key highlight features that we would say for Mindy would be first to kind of highlight the different engines that we use for it. So that would be Symmetrics and Simplicity as well too. This is what allows Mindy to cover a wide range of simulation situations and environments. It also installs and runs locally on your PC as well too, so you do not need Wi-Fi to run any simulations.
Nice.
You could be hiking, you could be in the middle of anywhere, and if you get a call and you need to just start running a simulation on our part, you can do it right there as long
Good
as you
to
got your
go.
laptop on you. Yeah, and I think the last point, we have a bunch of different models that are inside Mindy, so both proprietary like ICs as well as very generic components as well too. So you have no shortage of the different tools you need to get whatever you need to get running.
Nice. And so two of the things you mentioned, symmetrics and simplest. Do you
Yes.
mind breaking that down a little bit further?
Oh yeah, absolutely. So I think we have a little screenshot right here of the welcome page for Mindy. So on the top left corner, there are both the symmetrics and also simplest schematics that you can open up. Symmetrics is our more general analog and mixed signal simulator that we have. It includes the enhanced spice simulator as well as the schematic editor and also waveform viewer as well too. So very general in that way. Simplest is more on the complex side, so it's able to deal with our switch mode power systems in that way. So both kind of work in tandem to basically provide an environment that covers any simulation situation you could find yourself in.
Got you. And so you mentioned that there were other design analyzers within Mindy. Do you mind breaking those out?
Oh yeah, for sure. So it's actually a new feature that we had in our 8.2 release, but it's still very valuable right now. So if you open up a navigation tree in Mindy, you will see that some of the parts that we have that are newer have these design analyzers available for them. What it allows for is just very, very quick component selection around the part that you're using in that way. So I believe on the next slide, we'll be able to see what it actually looks like. So here you can just adjust the component values for anything. I believe you can start with inputs and then also go to system components and change whatever you want there as well too. And then this design analyzer will basically compensate and give you the most optimal output in that way for how to get a schematic that works well. So, and then from that, after you get the design analyzer to pick all the components you want, you can just take it straight into the schematic editor and very quick that way.
Pretty easy.
Yeah, pretty easy. Definitely.
So that's Mindy, and then we have another tool associated with this that has my
Yes.
favorite acronym within all of Microchip. Don't get angry, get mad. Please talk to the people about it.
Yes, get mad, definitely. That's our MPLab Analog Designer. It's our new online product selection tool. It basically helps any user, whether they're coming from scratch and just trying to find out what solution they need to find a solution, or if you're going back on your design, kind of refine it a little bit as well too. So I would say the first highlight that I'll talk about is the streamlined interface. So all you need is very, very few inputs. So parameters around the input voltage and output current that you need. And it populates a bunch of different solutions that may be relevant for your design in that way. Beyond that, the integrated design generators also are a great place to start as well too. You can do so much there from actually kind of changing components and finding what you need, which I'll show you later on as well too. So let me clear my voice really quick.
You're good, don't worry. It's all good.
Thank you for that. Hopefully it wasn't too loud in the mic. And the last point would be also the easy transition from solution selection in MAD into Mindy and validating the solution you chose as well too. So it's
Nice.
a very, very quick bridge that way too.
So I think we have a actual a demonstration of the GUI that they would experience.
Oh
right?
yeah, we have some screenshots so you can see what it looks like right now. So here we have MPLab Analog Designer. So this is the page you would see after you were on the landing page and you pick the different parameters that are relevant to your design. It'll populate all the different solutions that we have available. So starting with the eval boards at the top, you can see them right there. This is for buck regulators, I believe, the one that we're seeing.
Yes.
And below we also see the different design generators as well too. So from here you can just click Start Design on any of them and then be able to come to here, where at least this is a design generator that we're seeing for a particular part in this way. I believe this is a boost regulator in that. And then here, what basically happens is you can change any of the component values, and then the MAD will basically reanalyze and basically tell you what the optimal different components around your system needs would be that way.
Nice.
So pretty quick and very convenient in that way too.
And so I have a quick question. On the
Yeah.
previous slide at the very top, I see that there's a login section.
Yes.
Is that the same login that Pierce was talking about?
Yes, the same My Microchip login that you would need. So you have to come into MAD and play around a little bit, see what solutions you can find.
Right.
But then if you were to start designing, you would need to have the My Microchip login to get to this page.
Cool. And so let's say that we've picked out the design within MAD, we've configured it to our heart's content, and we're ready to take it further. Where would we go?
You would go straight to Mindy.
Nice.
Yeah. So very, very easy. From once you pick the design that you would like and you pick all the components you need, you can directly just take that schematic out and take it straight into Mindy. No copy paste needed in that way, or trying to just remember what components you got for different resistors or caps,
Right.
you can just take it straight in there and start working and validating immediately.
Super convenient.
Very, very convenient. Yes.
They're both free, right? So
They are both free as well too. So
I love it.
Yeah.
So both of these are new programs that are under constant development. What are some of the new features that you're excited about?
So a new feature that we added into MAD recently is actually the feature to compare solutions very quickly. A great feature because you can literally just go to the top right corner and you see these compare boxes. You click on I believe we can do up to like around 4 solutions right now, and you can compare them at a very quick glance. And then what comes up is basically right here, almost a checklist view on different features that both these parts have. Kind of they stack up against each other, what has what doesn't have what, compared to topologies as well as efficiency as well too. So it's a pretty powerful feature to have because you can see a lot in one glance. So
Absolutely.
Yeah, absolutely.
And so a lot of good information. Do you mind summarizing for the people at home why they should want to choose Mindy and MAD?
No, absolutely. So yeah, we have this slide right over here that kind of tells you kind of the flow of why this is beneficial to you. I'm sure you've made your own deductions as to how it's relevant to you, but then overall, MAD and Mindy are designed to help simplify the product selection process for your designs. So you saw with MAD how easy it is to just put in a few different parameters, and then you find the solutions you need very quickly in that way. So from there, you can also run preliminary tests very quickly into Mindy, as we saw. The transition between them is very seamless for that as well too, and basically it just helps you not to go to the bench to try and work on these parts first, and realize you have to resolder everything because you messed up.
Right.
You'll start with Mindy and MAD, and then you'll be good to go in terms of just saving time and money with efficient design cycles. So on top of that, you can also catch any design errors that you may run into pretty early on as well with Mindy in that way. So overall, this all just leads to just a more confident experience for the user. You get our parts and you realize it's easy to find them, and then it's also very easy to validate that these parts will work in your design from there. And then, it just gives confidence that you can basically create a part and a product that's going to be good to your customer as well too. So, these parts are designed to help the customer succeed. So
I love it. And so, let's say they get started and they hit a snag. Where should they go for help?
A great resource we have is the MPLAB Mindy Analog Simulator Handbook we have online. So it's essentially just an online book that has 15 chapters, but it ranges from literally someone who's completely new to analog simulation and Mindy. They'll teach them how to just get started and how to use everything that's part of the interface in there. But then also it has specific examples for how to work through, work with linear regulators, MOSFET drivers, buck regulators, and such. So it's pretty comprehensive. But if there's anything that you have questions about that's not in the handbook, you can always reach out to experts like me or other people on my team as well too.
Nice, I like it. And so that brings us to the end of the analog focus, but if you're designing with a 32-bit MCU or MPU, we have a totally different tool suite for you. Brian, do you mind giving people some background about Harmony?
Sure. So MPLAB Harmony is a software development framework for our 32-bit microcontrollers, microprocessors. What it does is, effectively abstracts the various peripheral libraries, software libraries, away from the underlying hardware, which allows you to easily migrate up and down the chain. So it was originally introduced to support the 32-bit development efforts for our PIC32 MIPS-based microcontrollers. But more recently, it's been updated to also include support for our Cortex-M microcontrollers, as well as our Cortex-A and Cortex-A and ARM926 based microprocessor products. So if you're wanting to move up the chain and going from say a Cortex-M0 up to a Cortex-M7 for more performance, adding more peripherals, or access to more memories, just getting more functionality in your project, you can easily do that, and even moving up into the microprocessor space.
Gotcha.
So the fact, MPLAB Harmony has, again, the libraries built in. If you can go back to the previous slide, has all the libraries built in for the various peripheral drivers and services that are available on on the microcontrollers, microprocessor products. Also includes most of the common software stacks that you'd find that most customers are using: USB, TCP/IP, graphics, etc. And then there's also, along the ease of use line, hence the inclusion for today, is that it has a graphical device configuration. So similar to the MCC tool that Michael was talking about, There is a graphical configuration tool available within MPLAB Harmony called MPLAB Harmony Configurator. So it too allows you to easily see how the various peripherals interconnect. You can visually see how they connect and easily identify any potential conflicts that you may have. So also within the tool, you'll find lots of demos and examples to get you started, both within MPLAB Harmony or MPLAB X, and also from the MPLAB Harmony GitHub site.
Nice. And so one of the key applications we're seeing people use this tool for is actual GUI development. Do you mind talking a little bit about that?
Sure. We have a couple of different paths for graphical development or GUI development. One is centered around the bare metal and RTOS-based designs, which you'd use MPLAB X and MPLAB Harmony for. So MPLAB Harmony Graphics Suite is very well integrated into the MPLAB IDE, MPLAB development ecosystem. So what it eliminates is, some graphics development is done with third-party tools, and trying to integrate that into the application development can be a little cumbersome. So this removes the burden from having to do all the software integration from the third-party graphics into the application support. It supports all Microchip 32-bit microcontrollers and microprocessors, same as MPLAB Harmony runs underneath Harmony. So another one of the tools that we have is, even though our microprocessors do support RTOS bare metal based designs within MPLAB Harmony, still a significant portion of our designs is actually Linux based. So we have a tool for that on the graphical side as well. It's called Ensemble Graphics Toolkit. This too was designed and developed by Microchip to support our microprocessors. It is free, open sourced Linux graphics toolkit, again optimized to take advantage of the graphical hardware that we have in our microprocessors. And EGT is also already integrated into our mainline Linux support. So if you want to learn a little bit more about either of these tools or these tools and how we can help you get your next design off the ground, there is a talk track later today. Take a look at that. There's a couple of demos for both of these tools, also available in the demo showcase. I encourage you to go take a look at those. Or go to the Graphics Design Center. The link's in the lower right-hand corner of the slide.
Absolutely, and we're going to have those in the comments and the descriptions, and if you can't find it, just email us at livestream@microchip.com. So you bring up an interesting point with the Linux. We've talked about the software aspect, but do you mind expounding a little bit on the other side of that equation, our hardware support for Linux?
Sure. So I assume most of you on viewing are familiar with microcontroller-based design. Microprocessor-based design is a little bit different. Microcontrollers tend to have everything you need all integrated in there. The power management, the memory's all resident on chip.
Right.
The higher performing microprocessor, the geometries that we're using for that and the processors using don't necessarily allow to include all of that, so most of it ends up being external. Also, a microprocessor tends to have a memory management unit to access high-speed external DRAM. So one of the biggest issues that we've seen over the years through our tech support has been in the DRAM layout. So improper routing of the DRAM can cause all sorts of problems around the board, resulting in either poor execution or even no execution whatsoever. So our MPU system and package products actually integrate the DRAM into the microprocessor package, results in a much more simplified PCB layout with a lot better EMI performance, and in most cases results in a much smaller footprint as well. So we can you get the DRAM integrated into a single BGA with the microprocessor. Is a lot smaller, a lot more compact design than doing that discretely. Also, designing the DRAM interface with a lot of the constraints actually forces the PCB layer count to grow a little bit and making your board more expensive.
Right.
So our MPU SIPs can be placed on a four-layer PCB, just kind of lowering your overall system costs. And then the best part about the SIPs is because we've done all of the routing inside the chip. We've integrated the memory inside the device. It means you don't have to do all that on your own. You don't have to worry about any DRAM obsolescence issues because you're sourcing the DRAM from the microprocessor vendor. So no more issues like obsolescence, availability issues, pricing issues, market fluctuations for DRAM, especially now. And then dealing with any of the fallout like software updates that come up just as you're about ready to take it into production. You can't get the product. You have to go back and change the software because you had to change the memory. So using a SIP on your next design can help dramatically lower your design risk. So then we have another solution that we introduced. Started introducing these a couple of years ago. Our system on module products. So Microchip has 28 or so divisions that are developing products, and most of them can fit well around a microprocessor. So we've integrated the power management and the interconnect and the memory on a single-sided solderable PCB, which is our MPU SOM. So it solves a lot of the issues of doing that on your own. So it dramatically shortens the time to market for these products. They are all part of Microchip's long-term support strategy. So you can easily build that SOM directly onto your board, put that down onto your carrier board, put it alongside your OS, your non-volatile storage of choice for the operating system and your boot source. Whether that's SD card, eMMC, or even quad SPI flash, and we can even boot directly out of raw SLC NAND. So another one of the advantages of doing it this way is you can use the SOM for your early evaluation and development of the product all the way through to building prototypes, and then ultimately going into low volume production with our SOM. And because all of the main components on that board are Microchip components, we readily provide the design files, the manufacturing files that will allow you to build the SOM directly onto your carrier board, dramatically lowering your BOM costs, the overall system-related costs, with little to no changes in the software.
I love it. And so where would you recommend people go if they wanted to read more right now?
So, the main source for Linux information for Microchip is our Linux for SAM wiki. This is our Linux for SAM, our Linux distribution, the OS for our microprocessors. It is mainline Linux based. There are pre-compiled SD card images for all of our development platforms, both legacy platforms as well as new platforms. They're all supported mainline Linux, so you can take a legacy platform and develop that on the latest Linux kernel. We update the precompiled SD card images for all of these platforms on a regular basis. There's also so you can download those SD card images onto an SD card, plug it into one of our eval boards, and get up and running with one of our boards in a matter of minutes. There's also build from source instructions up here, so you can actually roll your own SD card image. There's links to various resources on our GitHub site, as well as some other tools, and then links to some training resources as well. So there is to learn a little bit more about Microchip's approach to Linux and a little bit more on the hardware related to the ease of use for designing microprocessors. There's a talk track for that actually coming up here later this morning, our Simplified Linux talk track. So I encourage you to check it out.
Absolutely. So that brings us to the end of the presentation portion, but I believe we have some questions from the booth. Wayne, what do you have for us today?
We have a few questions. We actually have some decent conversation in the chat, ranging from what equipment we're using here in the studio to
That's a good one.
Studio. So I'm going to start with Mike. Basically, Claudio asked a question. What's the difference between Microchip Studio and MPLab X?
So Microchip Studio and MPLab X. It's a fairly clear definition. So Microchip Studio is specifically for AVR and SAM microcontrollers. And it's going to stay around. It's for those people that were used to using it before we purchased that company, and it's going to stay around. And the difference is it only works on Windows, and then MPLAB X will work with every single one of our microcontroller and even microprocessor products now, and it's cross-platform. That's probably the biggest differences there. So Studio specifically for AVR and SAM only, MPLAB X, you can do everything. So.
Okay, awesome. Let's see, one more question while I got your attention. Where can people see an online demo of the new online MCC and online Express that you talked about?
So apart from just trying it out, we've actually got a talk track this afternoon. I'm showing how to integrate some analog into a microcontroller, and as part of that, we're actually going to do a demo that uses Express and MCC online. So
Nice.
I think it's 12 Pacific. So.
Yes, it is.
All right, awesome. All right, let's see. For Josh, how often do Mindy and MAD models get updated?
Okay. So for Mindy, we do have a queue of models that are on the way right now still. So they were constantly trying to either go back and create models for existing parts or for new parts that are coming out as well too. But then they're typically released on a quarterly basis for us for Mindy. For MAD, it's more of it's kind of perpetual right now, so it's an ongoing cycle. So you can find new parts within MAD as you're just looking day to day as well too. So, but then typically I'll look out for Mindy on a quarterly basis and MAD. Still a very new tool right now, so we'll keep on having more and more different models and design generators available on there too.
Okay, and how, if someone wanted to request a model, how would they do so?
If someone wants to request a model, they would have to get in contact with one of the product line marketers for those groups. So that could typically be done through like the field, and they'll get you contact with one of us, and we can get that added into the queue for you. Definitely will provide the support that you need just in terms of communication-wise and getting those models into queue so you can use them as well too.
Okay. And we also have a question from Rodrigo, sorry, I'm messing up your name, down from LinkedIn. I think he's in, if I remember correctly, I think he's in Brazil, but I'm not entirely sure. He asked a question about Mindy, and in comparison to Proteus VSM Simulator. And I figured that's probably not a fair question to just throw out at the panel. So I called the Lifeline.
You're a wise man.
I called Josh's boss, and he actually gave me an answer to the question. So basically, just from a similarity standpoint, I'm reading here. Essentially, they're partially similar. It says the SPICE capabilities between Proteus and MPLAB Mindy may overlap. Proteus has some digital simulation capabilities not present in Mindy today, but Proteus will not be able to do the piecewise linear simulation that makes Mindy so fast for closed-loop control systems like motor drive or power supply designs. So that's kind of an answer to an overview answer to the question. I believe that Rodrigo is out using Proteus and just wanted to kind of get an understanding. All right, let's see. Who else should I? So Brian, I haven't given you any love or picked on you. Just
Not yet.
depending on your perspective. So you have a bullet on your slides that talks about mainline Linux support. What exactly does that mean?
Okay. So mainline Linux is the top level Linux kernel where basically all new changes and everything are implemented. All new security updates are implemented and patched. And more importantly, that everything that gets updated in there is essentially fully vetted by the community. So if you have a Linux distribution that is based on mainline, which is maintained on a regular basis and updated on a regular basis to include those new features. If you're using a Linux distribution that is based on that, and software that's related to that is all based on those mainline Linux distributions, then it makes life a lot easier because you don't have to do all that maintenance on your own.
Awesome. All right, let's see. One last question for you from PLC Worker. Can I use Harmony 3 for SOM1/WLSOM1 modules instead of Linux?
Sorry, I didn't. What was the question?
Can he use Harmony 3 for the modules instead of Linux?
Yes, that's the plan.
Okay, perfect.
Cool.
And let's see. I'm going to close it off with one last question. It's kind of an easy question from Claudio, who wants to know if we have a table that contains the name of the tools and their cost. And let's see. If you go to microchip.com and you go to development, the development tool section, you'll be able to kind of get a good overview of every tool that we offer. And everything that we've discussed here, what's the cost, Clifford?
It's free.
That's right. So, just so everyone knows. And I think we'll end the questions here.
Cool.
If you have any other questions that you weren't able to ask folks and you thought of, please send an email to livestream@microchip.com. And once again, Clifford's going to get them.
I will respond.
He'll respond.
Yes, I will. Well, cool. Thank you very much, Wayne. Like Wayne said, if you guys are furiously typing your questions, don't be afraid to just reach out, and I will personally make sure that our guys respond. I would like to plug one last time that in roughly 30 or so minutes, we're going to have additional talk tracks live and ready for you guys to actually interact with the people who designed and recorded these classes for you. And furthermore, if you missed one of our previous days, you can just go to this little drop-down menu right here and select whichever one interests you, whether it's e-mobility, ADAS, IoT, network infrastructure. We have a lot for you guys. All of those are available as recordings for you. And sorry about that. Make sure to check them out if you're interested. And once again, make sure you do the trivia so you can win some pretty cool prizes. But that brings us to the end of the live stream portion. I normally thank everybody, and I will thank everybody once again, but I just want to attach a little bit of special attention to the fact that we have done 6 of these back to back, and a lot of the crew that does this also does the coffee break, and for them it's been essentially 14 different live streams, all within the span of like 11 or so days, and I am very impressed and very proud of you guys, so thank you especially. But thank you for everybody in front of the camera, everybody behind the camera. It takes a whole mini army to pull this off. And we are not going to have a live stream tomorrow, but we will have future live streams and future coffee breaks, so make sure you tune in for them. And until then, stay happy, stay healthy, and I will talk to you later. Bye.
Thanks, everyone.
Thank you.